Okay, so here's a trig revision. So we start with a very simple trig proof. In other words, prove the cosine rule. Okay, it's a simple enough one. Again, probably you need to be slightly more accurate than I am, but construct a unit circle. So construct a unit circle. I'll do my best on this. Up 4, out 4, out 4, and down 1, 2, 3, 4. I'll do my best on this. Okay. Oh, this is woeful, but you get the idea. Okay. That bit there is particularly woeful. But anyway, construct a unit circle. Okay, with an angle in here of A. Okay, and a center of 0, 0. Now we have to put two other points, B and C. So we put B out here, and the length from 0, 0 to B, we call that C, and we put this coordinate in here. It's going to be C and 0. Okay, maybe so far. We'll make another, now we're going to make this obtuse angle, so we're going to put another side up here. So this becomes A, and we're going to call this side B. The length of it is B, okay? And this point here is C. Now, because we're using the idea of a unit circle, the coordinates of this point will be the coordinates of how you would do a unit circle. So it'll be B cos and B sine A. So that's the coordinates of it from the unit circle, because at each point on the unit circle is some derivation of cos of the angle by the sine, or comma the sine of the angle for your x and y. So all I'm doing is just multiplying them by b. Now, if this was a unit circle, I'd be multiplying them by 1. This is why you don't see the 1 in the unit circle, but you do see it here. So join the two lines, join the 2 points, and we'll call this side A. So obviously this is your A, B, and C. You're setting it up. Okay, so how do we do it? Well, we're going to get the length of BC. So the length of BC is gotten using our old friend Pythagoras, but a special version of Pythagoras, the coordinate geometry length of the line. It's going to be the square root. Now we're going to have to put what on these. We're going to have to put coordinates on these. So above this, I'm just going to put C and 0 as one of my points, and B cos A, comma, B sine A as my other point. So I'm just going to label these x1, y1, and x2, y2. You get the idea. So x1, y1, x2, y2. You can do it the other way around. Just I fancy doing it this way, just to show you it works in a minute which way you do it. So let's put them in. So the length is always going to be the square root of x2 minus x1 to be squared, C minus B cos A, plus y2 minus y1 to be squared. Okay, so we have to work this out. Let's square both sides to get rid of the root. So BC squared, which we know is A squared. So that's equal to A squared is equal to, let's square this out then. Square the left, square the right, and we'll do multiplying together and double it. That's minus 2BC cos A. Cos A. And what are we left with there? B, this squared, plus B squared cos squared A, plus B squared cos squared A. So that's this bit done. Okay, so this bit is this bit. Now I need to do this bit. I'll use a different color here. Let's do this bit. This is going to be an easier one to square out. Okay, because that's just going to be b squared sine squared a, because the 0 will mean that the other two bits don't exist, plus b squared sine squared a. Okay, so here's the proper bit done. Now, that leaves me with a squared equal to, let's try and tidy this up. We can factorize some things here. You still have a c squared, no help there, minus 2bc cos a, but both of them have b squared plus b squared in a bracket cos squared a plus sine squared a. That's 1, just so you know, from one of our identities. So now we've got a squared is equal to c squared plus b squared minus 2bc cos a. And that is what we wanted. Okay, so I hope that helps you. Right, now on to a little problem. So PQR is a triangle and S is a point on, what is it, PQ. So there it is. Our PR is equal to RS is equal to 5. So I'm just going to put that in. They're both equal to 5. Okay, and that's 8 and that's 10. And we want to find the angle PSR. So we want to find this little angle in here. Okay, so we have 3 sides and we want the angle. That to me shouts cosine rule. Okay, so let's put it all together. 5 squared plus 8 squared minus 2 times 8 by 5 by the cos of PSR is going to be equal to what's opposite PSR, another 5 squared. So that's 5 squared minus in a bracket 25 plus 64 divided by in a bracket minus 80. And then get the cos inverse of that answer. Oh, that's not right, you can get a fraction there. So I'll try that again. We've got 5 squared. So it's 25. 5 squared minus 5 squared minus 64 minus 64. Okay, divided by minus 80 is 4/5. Okay, and then the cos inverse of 4/5. Oh, do you know what it is? Can everyone see there? I still have this in degrees or in radians. Not following my own rules, am I? Cos inverse of 4/5. 36.87. There you go. Always check whether you're in degrees or whether you're in radians. Okay. Right. Let's move on to a bit more abstract. Trig. So, we got here now is the looks like basic kind of trig rules. So give it a read for a second. Nice. So find the sine of 2a and find the cos of 2a, and they give you the sine of a. Okay, so listen very quickly, very quickly. Okay, so get yourself a nice little sketch going here. So there's a. So the sine of a is going to be 1 over root 10. Let's find out the third side of the triangle. So that's going to be 3, isn't it? 3 squared plus 1 squared is 10, and root 10 will give you Pythagoras. So that's 3. So Now at least we have that bit of it. So now we can read off the cos if we want to. So the sine of 2a is, if you use your log tables, 2 times the sine of a by the cos of a. So it's 2 times 1 over root 10 by 3 over root 10, which is 3 over 5. And the cos of 2a, look it up in your log tables, it's going to be cos squared a minus sine squared a. So that's cos squared a. Well, cos of a is 3 over root 10, so it's 3 over root 10 squared minus 1 over root 10 squared, which is 9 over 10 minus 1 over 10, 8 over 10, which is 4/5. So there's a nice little kind of a doozy to get you going. Now, this is where it gets a little bit more complicated, okay, where you kind of need to pay a little bit of attention on these ones, okay? By expressing the sine of 3a as the sine of 2a plus a, find the exact value of the sine of 3a and give your answer in this form, okay? So let's look at it. They're hinting you here, sine of 2a plus a, that's the sine of a plus b. Now, if you look in your log tables, it's sine a, cos a, sorry, no, sine a cos b plus, I'm trying to do this out of my head, sine b. So now, what we have is sine of 2a. I'm just following the method of doing this. So that's the sine of 3a. And that's the same as the sine of 3a. I'll just split it up so I don't have to change this. I just need to pop in everything from there. So what have we worked out here? Sine, that's 3/5 by the cos of a plus the cos of 2a, 4/5 by the sine of a. Right, so 0.6 divided by 3 over root 10 plus, in the bracket, 0.8 multiplied by 1 over root 10 30/10 over 50. And it's in the form they want. Okay, so there's a nice one. Now, this one's looks a bit nastier. So, express 2 cos squared x plus 3 sine x minus 3 as a quadratic equation in sine x, and hence find all the values of x. Okay. Right, so we need to turn this into sine. So cos squared x, one of your first identities we learned was this one, remember? Cos squared x plus sine squared x equal to 1. That means cos squared x is equal to 1 minus sine squared x. So to substitute that in, that's 2 on 1 minus sine squared x plus 3 sine x minus 3 equal to 0. Multiply that out. 2 minus 2 sine squared x plus 3 sine x minus 3 equal to 0. Tidy that all up and change all the signs. So that's going to be a plus 2 sine squared x. That's going to be a minus 3 sine x. And then add them. That's a plus 1. So, well, listen, 2 sine x in one of them and sine x in the other. And it's a 1 and a 1, isn't it? And we need them to both be negative in order to get a positive. So let's try and work it out. Let's see what we've got here. We've got, I think that's going to be useless to us because this one will give us an actual identity. 2 sine x minus 1 equal to 0. Add 1 to both sides. So sine x equal to half. So we're looking for, okay? So let's deal with these. So we have to get the answer between 0 and 2 pi. So how many do we have? Well, listen, the first one, get your log tables to do this job, but I'll do it using the sine inverse 30 degrees. That's pi over 6. So that's pi over 6 is one of them. And then let's try and figure out the other one. That's in the first quadrant. Sine is also positive in the second quadrant. So that's 150. So take pi from pi over 6. It gives you 5 pi over 6. So there's your two of them. Now let's do it with the other one. Sine of x minus 1 is equal to 0. Add 1 to both sides. Sine of x equal to 1. And then in case sine of x equal to 1 is 90 degrees. So pi over 2, wouldn't it be? Yeah, pi over 2. So x is equal to pi over 6, pi over 2, and 5 pi over 6. Okay, cool. All right, that's done there.